Alright, welcome back to another Green Ninja Climate Science Series video. In this video, we're going to be tackling the big question of why do we think current climate change is being caused by humans? So we've kind of hinted at the various lines of evidence in previous videos, but in this video I kind of want to just review the different lines of evidence and kind of synthesize it into one kind of coherent statement about why scientists think that the current climate change that we've seen is indeed being caused by human activity. So I've kind of separated this into a few points. So the first point is just the fundamental physics of the greenhouse effect. So as I mentioned in an earlier video, John Tyndall was the first in the 1860s to demonstrate that different gases absorbed wavelengths or absorbed radiation differently at different wavelengths. So these are the greenhouse gases, and in this chart they're showing that, say for instance, water vapor here absorbs very strongly at around 7 micrometers of radiation, and that's a wavelength of radiation that the Earth gives off towards space. So water vapor selectively lets in shortwave radiation from the sun and doesn't let out longwave radiation from the Earth as easily. And so this basic fundamental attribute of greenhouse gases makes it very difficult to imagine how you would increase greenhouse gases without getting an increase in temperature. So this is just kind of basic physics, and it's one of the kind of key arguments for why scientists think that the current warming is being caused by the associated increase in greenhouse gases that we've seen from fossil fuel burning. So how do we know that that the current increase in greenhouse gases is in fact due to fossil fuel burning? Well, there's various lines of evidence, but just kind of a very kind of obvious one to look at is just the timing of when the greenhouse gases actually increased. So this is kind of like argument 1.5 here, that if again we just look at carbon dioxide here, but also here's two other important greenhouse gases, methane and nitrous oxide. We see that from the year 0 to the year in the 1880s, the amount of CO2 in the atmosphere was relatively constant. And then all of a sudden, when we started burning fossil fuels and putting CO2 into the atmosphere, then CO2 in the atmosphere jumped up by a ton. And so that makes perfect sense, right? But we know that just from looking at the timing of these things, that it's almost certainly due to human activities, the reason why CO2 went up in the first place, as well as these other greenhouse gases. So another piece of evidence would be to look at signatures of an enhanced greenhouse effect. So what I mean by this are lines of evidence that show that the greenhouse effect is getting stronger directly. So not just indirect lines of evidence like increases in temperature, but direct lines of evidence showing that the greenhouse effect is getting stronger. So how would you measure the greenhouse effect? So remember, in our Earth energy budget, the greenhouse effect came into play over here, where greenhouse gases are relatively opaque to long-wave infrared radiation coming from the surface of the Earth. So if you increase greenhouse gases in the atmosphere, which we have been doing, we would expect the outgoing long-wave radiation to space to decrease. And since we have conservation of energy, that means that more radiation should be coming back down towards the surface of the Earth. And so we have actually been measuring both of these things over time, and we have seen that this is exactly what is happening. So satellites have shown that long-wave radiation escaping to space has decreased, and the long-wave radiation coming back down towards the surface of the planet, as measured from surface stations looking up at the sky, has increased. So this is totally consistent with the physics that we would expect from the greenhouse effect, and makes perfect sense. Another line of evidence kind of attributing current warming to greenhouse gases would be the spatial kind of consistency of the warming. So in previous centuries, there have been large climate changes regionally due to changes in ocean circulations, for instance. So in the Atlantic, sometimes there have been events where ocean circulation changes have caused large warmings or coolings in the North Atlantic and kind of the opposite change in the South Atlantic. And so you could imagine maybe the current climate change is due to some type of ocean circulation like that. But because when you look at the globe, so this is just the warming rate of the globe from 1900 to 2012, if you look at the global surface warming rate, we see it's like pretty consistent throughout the entire surface of the Earth. And this is totally consistent with what you'd expect from greenhouse warming. Because CO2 is a very evenly distributed greenhouse gas, it doesn't matter where it goes, where its source is. So it can be from the industries in the Midwest United States. It doesn't matter. That CO2 quickly gets mixed globally around the surface of the planet, and that should cause warming basically everywhere, pretty much uniformly. And so that is indeed what we see. We see warming over the entire surface of the globe, and it's pretty consistent. I mean, there's differences because we expect, for instance, continents to warm faster than oceans. We expect the Arctic to warm faster than the equator. But overall, the warming is pretty consistent, and this is exactly what we would expect with a greenhouse gas, with greenhouse gases actually causing the warming. Another piece of evidence is that you could imagine perhaps there's a bunch of heat in the ocean, and maybe the ocean is releasing that heat to the atmosphere, and so you'd have a situation where the ocean would be cooling at the same time that the atmosphere would be warming, and maybe that's causing the warming that we've seen. But that can't be the case because we've seen that the ocean itself is warming as well. So if the ocean and the atmosphere are warming at the same time, then that really points to this idea that the energy is coming from a change in the energy balance at the top of the atmosphere, or the energy budget at the top of the atmosphere. So this is another line of evidence that shows that it has to be probably coming from the enhanced greenhouse effect. The third kind of piece of evidence is just when we look at climate changes of the past and we try to understand how climate has changed in the past, and we try to look at the current climate change, we see that natural climate changes of the past really do not explain the current warming that we've seen. So when we look over longer periods of time, like 400 million years, we see big changes in CO2 and climate, but these changes are extremely slow. These have to do with processes like the formation of continents and different biogeochemical processes that take extremely long periods of time to change. So a lot of these climate changes that we've seen in the past are just way too slow to be explaining the current warming. Even these Milankovitch cycles that we touched on, these are occurring at time periods of 10,000 to 100,000 years, and so you don't get a big enough change over decades or 100 years for these to be causing the current climate change. There are causes of natural climate change that could affect the Earth's temperature on the period of decades, and those are volcanic eruptions and changes in solar radiation coming towards the surface. So this is a very important graph that we're looking at here. So this top part is changes in radiation at the top of the atmosphere coming from volcanic eruptions. So every time you see a spike in this top part, you're seeing a big volcanic eruption which is essentially shielding the Earth's surface from sunlight. So we would expect cooling from that situation. And then this next line here are two different estimates of how solar radiation has changed over the past 1,000 years. And what we see, we can use climate models to essentially figure out how much of an effect these two things, volcanic eruptions and solar radiation, have had on the surface temperature of the planet. And so that's what these lines, these colored lines are. They are climate model simulations of the temperature, and they are overlaid with our best estimate of what the temperature actually was, and that's what this shaded region is. So we have observations, or our best estimate, coming from proxy records of what the temperature was over the past 1,000 years in the shaded colors. we have climate model simulations of what the temperature should have been based on changes in solar radiation and greenhouse gas, or solar radiation and volcanic eruptions. And what we're seeing here at the end, this is really important, is that the thick colored lines are climate model simulations that include this large increase in greenhouse gases at the end of the time series here. And the thin lines are climate model simulations that do not include this increase in greenhouse gases. So we've seen a large increase in temperature over the past 100 years, and climate model simulations that include greenhouse gases agree with that increase in temperature. And when you do not include greenhouse gases, then the climate model simulation suggests that we actually should have seen cooling over the past about 100 years. So this whole graph is kind of a long way of saying that the only mechanisms that could have caused warming on the timescales that we're talking about are solar variability and volcanic eruptions, but those two things are not moving in the right direction to have caused the current warming. So when we put those two things, solar variability and volcanic eruptions, into climate models, the climate models show us that we would have expected to see a cooling from those two from changes in those two variables. And the only way to get the warming that we have seen, that we have observed, is by including the observed increase in greenhouse gases in the climate models. So that is kind of a summary of why scientists think that the current climate change is being caused by humans.